How does a simple dead-end pipe called a drip leg filter your home's gas supply? Gas lines aren't perfectly clean. They carry condensation and microscopic trash that could easily jam your water heater. Let's track a water droplet and a speck of dirt rocketing downward through the main gas pipe. A mesh filter won't work. As it catches dirt, it would eventually clog and choke off your gas supply. Instead, plumbers use physics. At the intersection, the main pipe turns 90 degrees to the heater, but a capped pipe continues straight down. When the flow hits this junction, the lightweight gas easily makes that sharp right turn, but the dirt and water droplets have far more mass. Their forward momentum makes that sharp turn impossible, so they blow straight past the opening, falling directly into the capped pipe. And that speck of dirt and water droplet we tracked from the very beginning of the pipe, they stay safely trapped at the bottom, ensuring nothing but pure, clean gas reaches the sensitive control valve.
Behind the drywall of your basement, like right now, there is actually a designated breaking point. It's this piece of heavy metal infrastructure that is designed specifically to fail, to be torn apart, basically, so that your house doesn't have to be.
Right.
So today, we are looking at the unforgiving physics of plumbing and the incredibly high stakes of an everyday luxury. I mean, think about turning on your shower. You want hot water, you turn a handle, and within seconds, you are just surrounded by steam.
Yeah. It feels like magic, honestly.
It totally does.
Yeah.
But maintaining that illusion of magic requires a startling amount of rigorous defensive engineering.
Which operates silently, without any input from you for years or even decades at a time. The systems buried in our homes are really these master classes in anticipating disaster.
Yeah, and today we're taking you on a custom deep dive into exactly what is happening down in the dark of your utility closet. Our source material is this highly specific, boots-on-the-ground transcript from a YouTube channel called How to Plumbing.
Great channel.
Yeah, and we're looking at a video entirely dedicated to just one routine task: connecting a gas line to a new water heater.
Which, I know, it might sound like a super niche instructional video, but the details hidden in this one routine task are universal revealing about how we build resilient systems.
Exactly. And the mission for today's deep dive is absolutely not to turn you into a licensed plumber. Please do not go ripping out your gas lines after listening to us.
No, definitely do not do that.
Right. Instead, we want to uncover the hidden logic, the spatial foresight, and this brilliant concept of defensive engineering hiding right behind your walls. Okay, let's unpack this. Before we can even look at the completed gas line, we have to start with the raw materials and the incredibly precise, almost hostile physics of putting two heavy metal pipes together.
Because that foundation of physical security is really where the entire concept of gas safety begins. In the video, we watched the plumber pre-assemble the gas lines right at the control valve. And to do this, they're using components called black iron pipe nipples.
Which, just to visualize for you, are these short, heavy, really dark metal tubes. And they have threads carved into both ends.
Right.
The plumber is literally digging through a bucket of different lengths, sorting through them like heavy-duty puzzle pieces.
Yeah, and black iron is the standard there. Because it's incredibly rigid, it can withstand the pressure of natural gas without warping. But before any two pieces of this iron puzzle are joined, the plumber applies this thick, gooey paste to the threads.
Ooh.
It's an industry standard called pipe dope.
I just love that phrase, pipe dope. It sounds like, I don't know, something you'd buy in a dark alley in the 1990s.
It does.
But it's actually just a specialized thread sealant, and brushing it on seems pretty straightforward, but the part that really caught my attention was the golden rule of actually threading these pipes together. The plumber emphasizes that when you are tightening these fittings, you have to position them at a very specific angle, because you must never, ever back up on the thread.
Yes. You are hitting on a non-negotiable law of gas plumbing there.
Yeah.
You only move forward.
Right.
You tighten to reach your angle, and if you overshoot it, you cannot simply loosen it a quarter turn to adjust.
Which instantly made me think of the nightmare of putting together, like, cheap, flat-pack furniture.
Oh, absolutely.
You know the feeling. You're attaching a table leg, and you cross-thread the screw, you try to back it out to fix the angle, and suddenly you realize you've completely chewed up that cheap particle board.
Yeah, it's just ruined.
Exactly. The screw will never sit tightly in that hole again, and your coffee table is doomed to be wobbly forever. Except, in this scenario, instead of a wobbly table, the consequence of backing up on the thread is a highly dangerous, totally invisible gas leak in your basement.
What's fascinating here is that we culturally associate plumbing, especially working with heavy black iron as a brute force activity.
Oh, for sure. Just wrenching it as hard as you can.
Right. You grab a massive wrench, you heave on it with all your body weight, and you crush the metal together. But because natural gas is an entirely unforgiving substance, plumbing is actually a game of microscopic precision.
Because of the gas molecules.
Exactly. Gas molecules are incredibly tiny, like much smaller than water molecules, and they are constantly under pressure. They don't pool on the floor like a water leak. They actively seek out and push through the microscopic valleys between metal threads.
So that gooey pipe dope isn't just acting like a glue then.
Not at all.
It's essentially like a microscopic liquid gasket.
Yeah, it serves a dual purpose.
All right.
The threads on the iron pipe actually taper slightly. They get wider the further you screw them in, which creates this intense mechanical wedge.
Oh, okay.
But metal on metal rarely creates a perfectly airtight seal at a microscopic level. So the pipe dope acts as a lubricant first, so those tapered threads can wedge together as tightly as possible without grinding.
That makes sense.
And then it cures. It hardens into a physical matrix that blocks those microscopic valleys.
Meaning if you heave on that wrench, hit your angle, realize you went like a fraction of an inch too far, and turn the pipe backwards, you are physically tearing apart that cured matrix.
Yes, you've shattered the microscopic seal. And the dope doesn't just magically flow back together to heal the wound either.
Wow.
You have carved a permanent pathway for high-pressure gas to escape. To fix it, you would have to completely unthread the pipe, clean all the old dope off with a wire brush, reapply fresh dope, and start over.
That sounds miserable.
It is. Therefore, you have to plan your turns. You calculate the final angle so your mechanical tightening locks in place exactly where you need it. This heavy, sweaty labor is actually an exercise in profound spatial foresight.
And that spatial foresight immediately comes into play with the very first major structural component they add to this pre-assembly.
Right.
Because once you've mastered the threads, the very first thing the plumber builds isn't even designed to move gas into the heater. It's a component entirely designed to protect the system from itself.
The drip leg.
Yes.
Yeah.
Or, as the plumber refers to it in the source, the dirt leg.
Mm-hmm.
It is this 6-inch piece of black iron pipe pointing straight down toward the floor, just capped off at the bottom. It sits at a T-junction right before the gas makes its final horizontal turn into the control valve of the water heater.
Exactly.
And the plumber says its purpose is to catch condensation or, quote, any trash that may be in the line. The trash bypasses the valve entirely and just falls into the leg.
It functions as a completely passive, gravity-fed trap.
I had to pause the video when I heard that. Wait, trash in a gas line? How on earth does garbage get inside a perfectly sealed, high-pressure utility pipe?
It's a fair question.
I mean, I always imagined the natural gas coming into our homes was this hyper-purified, sterile, invisible energy.
Well, we prefer to imagine our utilities that way, but underground infrastructure is decidedly not a pristine laboratory environment.
To understand the physics, I was trying to picture like a high-speed car chase.
Okay, I like where this is going.
Imagine the gas is a nimble, lightweight sports car. It's zooming down the pipe, and it easily makes that sharp 90-degree turn at the T-junction to enter the water heater. But the trash, the water droplets, the rust, they're like a heavy, speeding dump truck.
Right, they have momentum.
Exactly. They have way too much mass and momentum to make a sharp 90-degree turn at that speed. So they skid straight ahead, missing the turn entirely, and plummet straight down into the capped pipe.
That perfectly illustrates the mechanics of momentum and gravity at play here. Gas is a vapor, so it can pivot instantly. Solid debris and liquid simply cannot.
Yeah.
This raises an important question, though. How do we design infrastructure that acknowledges the messy reality of the physical world?
Because the real world is messy.
Exactly. In a theoretical world, the utility company delivers 100% pure vapor.
Yeah.
But in reality, that gas travels through miles of underground piping that experiences massive temperature swings.
Which causes condensation.
Right. And the older iron pipes in the city grid naturally oxidize over time.
Yeah.
Tiny flakes of scale or rust shear off and travel through the line at high speed.
And a speck of rust sounds totally harmless until you realize what it's flying toward.
Exactly. The control valve. On a modern water heater, that is an incredibly delicate piece of machinery.
Yeah.
It has tiny, precision-machined orifices that regulate the flow of gas to the burner. If a single flake of rust jams that tiny valve open, you have a runaway fire hazard.
Oh, that's terrifying.
And if it clogs it shut, you have a dead appliance.
So the brilliance of the drip leg is that it requires zero electricity, zero sensors, zero moving parts, Just a heavy dump truck missing a turn.
Yep.
It is the ultimate admission that the world is imperfect, the gas supply is imperfect, so let's just build a tiny, localized prison for debris right here in the basement to intercept the threat.
And that philosophy of defensive engineering, anticipating inevitable problems, carries directly into the next phase of the assembly. Because after protecting the delicate internal machinery from debris, the plumber's next components are entirely focused on protecting the homeowner from future maintenance nightmares. Every appliance has a lifespan.
Nothing lasts forever.
Exactly. The layout of these iron pipes is actively anticipating the day this brand new water heater dies.
Which brings us back to that designated breaking point I mentioned at the start, the union and the cutoff valve. So the plumber attaches a fitting called a union, followed by a half-inch gas cutoff ball valve. The source is absolutely clear about the purpose of the union. When you inevitably have to replace the tank in 10 or 15 years, you use the union to separate the pipes right at that joint.
And visually, a union looks like a bulky collar between two pipes. It has a large threaded nut in the center.
Okay.
When you loosen that center nut, the two halves of the fitting simply pull apart. You don't have to rotate the long metal pipes themselves.
Which, as we established with the pipe dope, would break the seals all the way back to the wall.
Exactly. You'd have a massive headache on your hands.
Now, here's where it gets really interesting. The union is essentially a physical undo button.
Right.
But as I was reviewing the plumber's instructions, I got completely tangled up on the required order of operations.
Oh, the sequence.
Yes. The source states a rigid rule, quote, "Remember, always put the union before you put the cutoff valve."
The sequence is literally the difference between a routine repair and a catastrophic emergency.
Well, I found myself arguing with the video.
How so?
I was thinking, if my goal is to cut off the gas to replace the tank safely, shouldn't the cutoff valve be the absolute closest thing to the tank? Like, if the union is before the valve, aren't I unscrewing the pipe while the gas is still alive?
You're hitting on a very common point of spatial confusion here. It all depends on which direction you are facing.
What do you mean?
Before and after change, depending on if you are the gas traveling from the wall or the appliance looking back at the wall. Let's walk through the disastrous hypothetical you just proposed to clear this up.
Okay, let's trace it from the wall. The gas is coming out of the house's permanent plumbing.
Yeah. Right. You want the permanent shutoff valve screwed directly and securely onto that live pipe coming from the wall. Is the gatekeeper holding back the city's entire gas supply.
Got it.
Then, downstream of that valve, closer to the water heater, you install the union.
Oh, I see the disaster now. If I followed my own confused logic and put the union between the wall and the valve.
You would reach down to replace your water heater, turn off the valve, and then unscrew the union. But because the union is between the wall and the valve, the moment those two pipes pull apart, the valve stays attached to the water heater you're throwing away.
Oh, no.
And the pipe from the wall is now a gaping open hole, venting high-pressure utility gas directly into your face.
Wow. You would have bypassed your own gatekeeper.
Exactly. If we connect this to the bigger picture, good design inherently plans for its own safe removal. By putting the valve first, you turn the handle to the off position, sealing the explosive pressure securely inside the home's permanent plumbing. Then, you unscrew the union downstream. The water heater is now completely free and the house remains sealed. You can drag the dead tank up the stairs, bring a new one down, lock the union back together, and turn the valve on. You have isolated the failure.
And the plumber specifies they are using a ball valve, calling it the perfect type of valve for this job.
Because a ball valve is mechanically superior for gas. Inside that brass fitting is quite literally a metal sphere with a tunnel drilled straight through the middle.
Okay, so it's a literal bowl.
Yes. When the handle is in line with the pipe, the tunnel lines up and gas flows. When you turn the handle 90 degrees, the solid wall of the sphere rotates to block the pipe completely.
It's a physical, undeniable barrier. It's not just like a rubber washer pressing down that might wear out over time. It's a solid wall of metal.
Exactly.
Okay, so we've built this incredibly thoughtful armored gas line. Pipe dope sealing the microscopic valleys, a drip leg catching the heavy momentum of the trash, a shutoff valve acting as the ultimate gatekeeper, and a union waiting patiently to make the next decade's replacement easy.
A very robust system.
It really is. But what really elevated this deep dive for me was that the source material doesn't just deliver cold mechanical instructions, it places us right there in the physical environment.
The sensory details of the job site kind of bleed into the instruction, don't they?
Yes. For the entire duration of the assembly process, there is this loud, rushing sound in the background of the video.
Mm-hmm.
The plumber casually mentions, of course, the water that you're hearing in the background is the water draining out of the old tank. To me, that rushing water is the auditory ticking clock of the whole project.
It grounds the theory in reality. This isn't happening on a brightly lit workbench in a lab.
No, it's happening in someone's cramped utility closet.
Yeah.
That rushing water is a constant reminder that a family somewhere upstairs is currently shivering.
Yeah.
They're waiting for their hot water to come back on. The old tank is bleeding out on the floor drains right next to the plumber, dictating the pace. And speaking of the environment, there was another detail that genuinely made me laugh, but it really speaks volumes about the reality of the work.
Which part?
The plumber shifts focus to the brand new water heater, looking at the top where the actual water lines connect. And they point out that the manufacturer stamped the words hot and cold in massive letters right next to the intake holes.
Ah, yes, a seemingly obvious addition.
Right. I joke to myself, like, do seasoned professionals really need hot and cold explicitly spelled out for them?
Right.
These are technicians managing explosive gases, spatial geometry, and microscopic threading tolerances. It felt a bit like printing "this side goes in mouth" on a spoon. I would assume a pro just intuitively knows which side of the tank is which.
I think we have to vigorously defend the labels here.
Really?
Yes, it is very easy to view those massive letters as overkill from the comfort of an office chair. But put yourself in the physical reality of that basement. You've just spent an hour maneuvering a 300-pound awkward metal cylinder down a narrow flight of wooden stairs.
That's a good point.
You're working in tight quarters, probably banging your elbows, sweating under a single harsh hanging bulb.
Your body is totally exhausted.
Right. Your entire nervous system is taxed. Physical labor carries an immense, underappreciated cognitive load. When you are wrestling hundreds of pounds of machinery, your brain's bandwidth is entirely consumed by leverage, balance, and ensuring you don't drop a tank on your own foot.
That takes a lot of focus.
It does. And then you transition immediately to hyper-focusing on the precise mechanical angles of a gas line to prevent a literal explosion.
So by the time you reach for the water pipes, your mental battery is just deep in the red.
Exactly. The moment you are physically exhausted and mentally depleted is the exact moment you might accidentally cross the cold water supply line with a hot water output line.
And then the whole system doesn't work right.
Right. In that high-pressure environment, idiot-proof labels are not an insult to a professional's intelligence. They are a critical safety net.
I see.
They allow the plumber to offload a tiny piece of cognitive processing.
Yeah.
They don't have to remember or deduce which side is which while holding a blowtorch. They just read the label.
It's defensive engineering applied directly to human psychology.
Beautifully put.
Don't make the human rely on memory when their arms are shaking from carrying a tank. Just label the metal.
Yep.
So, what does this all mean? We started by talking about the everyday luxury of turning on a tap and instantly getting steaming hot water. And what diving into the plumbing source material has revealed is that this magic is entirely built on an invisible foundation of radical foresight.
It is an architecture built on the assumption that things will eventually go wrong.
And preparing for it beautifully. I mean, every single choice in screwing together those black iron pipes is a conversation with the future.
It really is.
The pipe dope creates a microscopic seal that will hold strong for decades. The drip leg harnesses the physics of momentum to catch the rust you didn't even know was coming. The heavy brass ball valve locks the danger behind a physical wall. And the union just sits there, waiting patiently to buy you an easy afternoon 10 years from now when the tank inevitably rusts out. It makes you deeply appreciate the hidden, unglamorous infrastructure behind your daily shower. It is a philosophy of anticipating failure, admitting the world is imperfect, and designing around it.
Which stands in incredibly stark contrast to how almost everything else in our lives is engineered today.
How so?
Well, next time you look at a modern appliance or a sleek tech gadget in your home, ask yourself, where is its union?
Oh, wow. That's a great question.
In our increasingly disposable world, where everything from our smartphones to our refrigerators is glued shut, sealed tight, and designed to be thrown into a landfill the moment a single internal component fails. What happened to the how to plumbing philosophy?
It's like we just abandoned it.
We really did. We seem to have lost the expectation that the things we rely on should be designed from the very beginning to be taken apart, repaired, and replaced piece by piece.